某果手机居然也会炸。一位外国博主在测试某果手机时，爆炸的威力犹如一颗手榴弹。如果人拿着手机走在大街上，爆炸起来，后果不堪想象。接下来我们一起跟随这个博主看看爆炸的全过程。
Hi there guys, I'm Chris Bowden and welcome to the Geek Group. Today we are in the Leonard Street lab, specifically our high voltage lab, for a little bit of mail-in fun. This is a first generation iPhone and it was sent to me by John Waskey, who's one of our Geek Group members, and he sent me a letter. It says, "Yo Chris, sorry it took so long for me to get this off. You know how it goes. Anyway, do whatever you want with this puppy. I'd love to see Thumper eat it for lunch, if at all possible though. Take care and good luck with everything." Thank you, John. We have a first generation 8GB iPhone. We've never put one of these through Thumper, but it could be kind of fun. Now, a lot of people out there don't know what Thumper is, so while I put this in the thing, I'm going to give you the basics of Thumper. Thumper is a energy impulse demonstration made from a large capacitor bank comprised of about 200 separate capacitors that are 2,000 microfarads each at 450 volts DC. They're wired in series strings of 4. Now see, we have to figure out how to get this in here because there's so much. Oh, I think there's enough aluminum there that I can, yes. All right, we're going to load the phone directly into the Thumper discharge stand, but because it has some coatings on it and parts of it might be plastic and that, I'm going to put an initiator wire around it, and this is just a small piece of aluminum wire that will help it get started. And we're just going to give this one good wrap right around and then pass it off to the other end. And we'll just hook this around under here. We'll wrap this around over here. And we'll just wedge the iPhone right in the middle. Actually, I'm going to bring that right up around there. Make sure we've got a good electrical connection. You just rub it and crimp it down tight. There. Now we've got our iPhone loaded into Thumper, ready to go. So now let's go charge the bank. Thumper can handle a maximum charge of about 1,800 volts nominally, and it can handle a maximum energy at discharge of about 80,000 amps, which gives us right around 140 million watts of energy. So it's pretty ferocious. This is all straight DC. We control it from here, and we use the big red button of science to set it off. Now, it's actually triggered pneumatically, and we have a safety system in order to dump everything back down. So we're going to arm the system now and charge it up. Now, the numbers you see here are the actual voltage on the bank, so we just crossed 100 volts. So what we're going to do is charge this up to 1,600 volts at 80,000 amps, and over 3,000ths of a second or so, we're going to dump all of that energy into a first-generation iPhone. What happened to it? It went boom. That's what happened to it. All right, so there's our finished iPhone 1G. You can actually see that the aluminum evaporated and deposited all over the front. The energy went in over here, blew the cover off, went out over here. You can very clearly see the points where the energy went through it. I think we should try it again just to see what happens, and if there's anything left, we'll run it through an equipment autopsy. So let's try that again. All right, so that's the second blast. We found the bottom. There's the bottom, which is just plastic, so that's why it didn't conduct. But there's what's left. Now we're going to give this some time to cool off because it's rather hot, and then we'll give an equipment autopsy and see what we get.